This is Chapter 8, Balancing and Identifying Types of Chemical Equations, Introductory Chemistry at Mineral Area College. So on the first example, I noticed that on the left side there's only one fluorine, and on the right side there's only one fluorine. There's two fluorines, and so to balance that out, I'm going to put a 2 for my coefficient in front of the LIF. But since I put the 2 in front of there, that means that there's 2 lithiums, and there's only one lithium over here. And you notice how there's 2 chlorines over here. So what I'm going to do is I'm going to also put a 2 in front of the LiCl, because now there's 2 lithiums on both sides, and there's 2 fluorines on both sides, and there's 2 chlorines on both sides as well. And since there are 2 compounds, and all we're doing is sort of like switching the cations and anions. So Ca, Cl, the Ca and the Li, they're going to switch places, which produces CaF and then LiCl. So that's going to give me a double displacement reaction. I think the next one is going to be fairly simple. On the right side, I know that there's 2 potassiums, and so to balance that out, I'm just going to have a 2 as my coefficient in front of the potassium on the reactant side. And so it's all balanced out now. There's 2 potassiums on the left side, there's 2 potassiums on the right side, there's 1 magnesium on the left, 1 magnesium on the right, 1 oxygen on the left, and 1 oxygen on the right as well. And so since the potassium and magnesium are only switching places, this is going to be a single replacement reaction, because notice how the only thing that's being switched are going to be the cations of the reaction, which is going to be potassium and magnesium, which turns into K2O and then magnesium as the products. Next, the first thing for example 3 that sticks out to me the most is I notice how there is 4 hydrogens on the left side, and to balance that out, I'm going to put a 2 in front of the H2O, because then there would be 4 hydrogens total on the right side of the equation as well. And so now all I gotta do is just balance out my oxygens. So now I have 2 oxygens plus 2 oxygens over here, which is 4 oxygens total on the right side. And to balance that out, I'm going to put a 2 in front of the O2 over here on the left side to make 4 oxygens total. So now there's 1 carbon on the left and the right. There's 4 hydrogens on the left and the right as well. And there's 4 oxygens on the left and the right as well. And so since this is something reacting with oxygen to produce carbon dioxide and water, this is going to be a combustion reaction. On example number 4, I noticed that there's 2 oxygens on the left side, and so to balance that out, I'm going to put a 2 in front of the MgO to make 2 oxygens on the right side. And since there are 2 magnesiums on the right side, I'm going to put a 2 in front of the magnesium on the left side. And so now we have 2 magnesiums on the left, 2 magnesiums on the right, 2 oxygens on the left, 2 oxygens on the right. And since it's like 2 items sort of combining into one for the product, it's going to be called a combination reaction. It's also known as synthesis as well. For example number 5, the first thing I notice is that there are 2 oxygens on the right side, and so to balance that out, I'm going to put a 2 in front of the HGO. So now I have 2 oxygens on the left side, and I also have 2 oxygens on the right side. But to balance the 2Hg on the left side, I'm going to put a 2 in front of the mercury on I'm going to put a 2 in front of the mercury on the right side as well. So now I have 2 mercuries on the left side, 2 mercuries on the right side, 2 oxygens on the left side, 2 oxygens on the right side. And since this is just sort of this is one reactant, and it's sort of splitting, it's sort of decomposing. This is going to be a decomposition reaction because remember, combination and decomposition reactions are just opposites from each other. So if this reaction was reversed, it would be, and if magnesium oxide was going to be the reactant, and then it would be a decomposition because then it's splitting up into two different products. And also, if this was going to be, if the mercury and the oxygen, if they were both going to be my reactants, and like again, if this reaction was reversed and this is the product, then it's going to be a combination reaction, just like example number 4. So just remember, for combination decomposition, it's just opposites, and generally I feel like the names of the reactions sort of already like tell you what the reactions are actually going to be about. And so those ones I feel like are really easy to remember. Combustion reaction, to identify that really quickly, all you need to remember is that it's something reacting with oxygen to produce carbon dioxide and hydrogen and water. And then for double replacement reaction, it's just usually the cations of an equation being switched. And then single replacement, it's usually just the just two ions in an equation being switched. So it goes from potassium plus magnesium oxide to potassium oxide and magnesium. Okay, it's just two sort of ions being switched in an equation.